Hello, everyone. Today, in this section, we are going to cover the next section in your FE manual structural analysis. It talks about the beam stiffness and the moment carry over. So, what is beam stiffness? Stiffness is you will going to see it in your FE manual. The equation is given as KAB, um, and we are going to see for a pin and fixed support, and then we are going to see also the pin and pin support and fix support. So which means that this is a pin and a fixed support, and then this is a pin and pin support, and then we'll have fix and fixed support. So these are the types of question you can expect for beam stiffness. The calculation is the formulation is already given in your FE manual. And then for the beam rotation for the same beam, you can see that if you're going to put the same beam, and so it will see that it asks for the beam rotation. So we know that if there's any moment applied, this beam will be rotating in this direction, in this behavior. And so you'll see that the rotation here is equal to 0. Your rotation theta is equal to 0, and theta here will have some value. And in this case, if you're applying a moment, you'll see that both of this will have some theta, and this also will have some theta. And in this case, you know that if even if there's any moment, generally there's for fixed cases, the moment will be generally due to settlement. If there's a settlement, we know that the beam will still equal to 0. The rotation will be equal to uh, 0. Okay, so this is due to rotation. And then we also going to see the moment carryover. So for example, in a pin and fix, if this is the moment you apply on the beam at one in your pin support, then the question is how much is going to um, carry over or redistributed to the fixed support. And then if this is the moment you apply M on one support, then the question is how much will be carry over to the uh, pin support. Okay, and but we also know that pin support moment will be 0, so there will be no moment carry over. And then in this case, if this in this case, if the moment at fixed support due to the settlement, it will cause a moment of m, then the what is the moment generated at the another fixed support. So that's what we're going to see in this video. So in this case, all you have to do is find the stiffness KAB at joint A, because you have two flexural stiffness. One is at joint A and one is at joint B. So in this case, the stiffness KAB over at joint A will be equal to 4EI over L. This is when you apply the load over MA, and KAB of at joint B will be equal to, you'll see that in this applying a moment MA in at the joint A, and how much of this moment will be carried over to the fixed end, in that case MB, and that will be equal to AMA over 2, which means that this moment that you apply in the joint A will only carry, or will only um, carry over by half of it to the joint B. So if that is true, then if the stiffness at joint A is 4EI over L, then your stiffness of AB over joint B will be 2EI over L. And if you still get confused, remember that MA is equal to KAB over A theta A, and that will be equal to um, and KAB over A is equal to 4AI over L, and it is given that MB is equal to MA over half, so which means that KAB over B will be equal to 2AI over L. And L is given to you 12 meter. So basically all you have to do is 2 EI over 12, and that will be EI over 6. So that will be your stiffness for KAB over joint B, and stiffness for KAB over joint A will be 4AI over 12, which is equal to EI over 3. So that's what you can expect from beam stiffness um, in a in a given beam problem. Then after that, you are going to see we're going to talk that um, you can expect a question. Another question that you can expect is, if I apply a moment at a roller support A, which is 5 kilonewton meter, how much of the moment will be carried over to the fixed support B? And this will be MB. And we know that MB will be equal to half of the moment applied at joint A will be carried over to the support B. So that means this is 2.5 kilonewton meter. Okay, so you can also expect a question that what if you have both a pin joint and a roller and you're applying an MA equal to 5 kilonewton meter. How much of the how much of this applied moment will be carried over to a support B? And support B is a pin joint, and pin joint does not resist any moment. So which means that this moment will be equal to 0. So please uh, make sure that you have to look what kind of the end support it is. If it is a fixed support, then half of that moment will be carried over to joint B, and if joint B is a pin support, then moment will be equal to 0. Okay, and then another question that you can expect is, what if you have both and fixed uh, fixed n, and then this beam will settle by some distant delta, and then because of this settlement it will create a moment ma, let's say equal to 5 kilonewton meter. Then how much of this moment ma will be transferred to the end beam B? Okay, so for this case, both the ends are support, both the ends are fixed end beam, and this moment is created by the settlement delta, or relative settlement between the initial length delta, and because of this settlement, it created a moment m a is equal to 5 kilonewton meter, and both ends are fixed, and this also will created MB will be exactly equal to MA, and that will be equal to 5 kilonewton meter. So please make sure that if both ends are fixed, then the moment will be the same. But if one end is roller, then it depends on what type of the end condition is. If it's a fixed, then it will be half, and if it's a pin, it will be equal to 0. So that's what moment carry over means. So how much of the moment will be carried over to the other support. Okay. And now another question that you can expect is, what is if I apply a moment equal to 5 kilonewton meter, how much of this moment will rotate at end A, or at the joint A? So for this, we know that use that theta A is equal to uh, MA by KAB over A, and that will be equal to, so MA L 4 EI. And if you put in your calculation 5 kilonewton, L is 12 divided by 4 EI, so this will be 15 EI radian. Okay, so your slope or your rotation at joint A will be 15 over EI radian. What will be the rotation at joint B? Because there's a fixed beam, rotation will be equal to 0, so there's no slope in a fixed end. Okay, so in this case, your theta B will be equal to 0, since it is a fixed beam, and we know that for fixed beam the slope is equal to 0 at the joint B. And now you can ask questions that, okay, okay, that I understand that if it's fixed, slope will be equal to 0. What if the another end is a pin joint? the joint B is a pin joint and applying the same moment MA. And if you're applying the same moment MA, you will see that your beam will deflect. It will deflect in this condition. More rotation will be at joint A than joint B. So because of that, you'll have your slope theta A, and then you have your slope here, or the angle theta B. So what will be my theta A? What will be my theta B? Well, for this case, you will find out from your mechanics of material section, page 140, and you can find out what is the value for theta A and what is the value for theta B when you're applying a load MA at joint A. Okay, so that's all about uh, beam stiffness and moment carryover, and also for the absolute maximum moment and absolute maximum shear. Okay, thank you.